phenol, we have to go for preparation of aldehyde and ketones. That is from basically Grignard reagent. That is a very important topic. So we will complete this, but after this. So we were completed up to this benzene sulfonic acid. Now the next preparation of phenol is from cumene. From cumene. So do you know what is cumene? We will talk about this cumene. Cumene is a compound in which this is cumene is a common name. So CH and this CH3 and this CH3. So this is cumene. Or cumene is a common name. So when we are going to react this cumene with O2, this cumene will be oxidizes, and everyone knows what is oxidation. That means addition of oxygen. So between this carbon and hydrogen, this two oxygen will be added. That means cumene is oxidizes. So now you can see, we can write COOH, and the rest is same. CH3 here on the top and CH3 on the left. And this is known as basically cumene hydro peroxide. Cumene hydro peroxide. First, we have to oxidize this cumene to cumene hydroperoxide and then react this cumene hydroperoxide with H plus, that means acid in the presence of water, or react with water in the presence of acid. Then we will get, you know what we will get? We will get phenol and CH3, C double bond O, CH3 ketone. So what happens here? Basically, this part will be eliminated and this OH will be directly connected to this carbon. So this is how we prepare phenol from cumene. Please write it and then let me know.
Done, sir.
Very good. What about you, Hamza? Hamza,
Yes, sir.
done?
Yes, sir.
Very good. So basically, in yesterday's class, I forgot to taught you about the preparation of aldehyde and ketones from Grignard reagent, which is very important. Preparation of alcohols from Grignard reagent. So you have already heard of this term Grignard reagent in the previous chapter, haloalkane and haloarine, and that is basically RMGX. And I already told you that this RMGX is very reactive in nature. This is very important. So how does this Grignard reagent react with ketones or basically carbonyl compounds to give you alcohol? So it's very important to write some points about this. Alcohols are also prepared, or alcohols are produced by the reaction of Grignard reagents with aldehydes and ketones. With aldehydes and ketones. Sneha and Hamza, please let me know about the previous lecture. I had explained what is carbonyl compound. Do you have any doubt in that? What is carbonyl compound?
No, sir.
Okay. So please write this point, then I'm going to start the mechanism of this.
Done, sir.
Done. Hamza,
Yes, sir.
very good. Proceed between aldehyde and Grignard reagent or ketone and Grignard reagent. First of all, there is a carbonyl compound which can be aldehyde or ketone. First of all, please let me know which one is aldehyde and which one is ketone. Above one is ketone or aldehyde, or the down one is ketone or aldehyde, below one, bottom or top. Sneha, can you tell me the first is ketone or aldehyde, or the second is ketone or aldehyde?
The first one is ketone energy.
What you just said, the first one is ketone.
No, sir. The first one is aldehyde and the second one is ketone.
So there is a minute difference. If this place covers, or at this place, if alkyl group will come at the same, at the both place, that means that is ketone. And in between these two places, if one of the bond will be connected with hydrogen, that means that will be aldehyde. So this is basically aldehyde and this is ketone. So alongside this, if both the sides are alkyl group, that is ketone. And alongside this, if one of the side is covered with hydrogen or connected with hydrogen, that means aldehyde. So basically, I am going to do this for both the generalize. So if this is going to react with RMGX, so can you tell me which one is more electronegative? R, that means alkyl group, carbon, R means carbon group, carbon or magnesium, which is more electronegative, R or Mg? Just answer me. It's very simple. Electronegative. Which one is more electronegative, R or Mg? So basically, R, that means carbon is non-metal, non-metal is electronegative. That's why there will be delta negative, and metal is electropositive. It will be easily donating its electron. That's why delta positive. Now see, oxygen is the most electronegative element. So what it will do? It will attract or withdraw electron from carbon. That's why on carbon there will be positive charge, and oxygen, since oxygen is gaining or getting electron or withdrawing electron from carbon, there will be negative charge. Is that clear to everyone? Please do respond.
Yes, sir.
Okay, thank you. Now it's very simple. What you need to do is just, what is the nature of charge? Positive attracting negative, negative attracting positive. So you can see this is the negative charge. So where it will go? It will go towards the positive. And there is negative charge. Where it will go? It will go towards the positive. So what will happen here? It's very simple. First of all, you are going to break one of the bond between carbon and oxygen, and it will be like this. And this was bond earlier. Now see, this is the negative and carbon has positive. So R will be coming with C and making a bond. Now you can see this will have negative charge and Mg has positive charge. So Mg will come like this, Mg plus and X. Is that clear to everyone? What you need to do, it's very simple. Carbon oxygen double bond, just break one double bond. Oxygen is more electronegative, that will have negative charge. Carbon is less electronegative than oxygen, that means that will have positive charge. Now come to the Grignard part, RMGX. R will have negative charge because carbon containing group. Carbon is more electronegative, that's why delta negative, that means negative. And Mg, that means metal, which will have positive charge. So this R negative will go to this carbon because it will have positive charge. And this Mg plus will go to O minus because it will have negative charge. And this is called adduct, or we can say intermediate. Basically, this reaction carried out in two steps. In the first step, we will get an adduct, which is intermediate. After this reaction, we will do hydrolysis and then we will get the main product. So first of all, write up to this and please write it and let me know if you have any doubt in this.
Done, sir.
Very good. What about you, Hamza?
Yes, sir.
Yes. Now the second step, in the second step, we do hydrolysis. What does hydrolysis mean? So basically it's very simple. You are going to add water, hydrolysis. So basically water has two parts, H plus and OH minus, H plus and OH minus. Again the same process, again the same process. This H plus will go to the negative part because positive will attracted by negative and negative will be attracted by positive. So what we will get, see, Cr this, then O minus. With O minus, which one goes? Hydrogen. So you can see this will have negative charge, this will have positive charge. So this they will be they will be cancelling with each other. The charge will be cancelled with each other, plus minus, and it will be alcohol now. And now you can see Mg plus, Mg has plus charge and this OH has negative charge. So this will be the byproduct, byproduct, and this will be the main product. So please do it and let me know when you are done with this. Then I'm going to give you some question. Which is very easy.
Done, sir.
Hamza,
That is done.
very good. Now see, I'm going to give you HCHO reacting with RMGX. Now, first of all, I'm going to react with this CH3MgBr. Then you will get something A, and whatever you got the adduct, just do hydrolysis and let me know the main product B, and C that will be constant in all reads. And if you are unable to do it, please let me know. I will explain it. Are you done with this, or should I explain?
Sir, can you do this?
Yes, it's very simple. And please be focused here. It's very simple. Fawaz, why were you absent yesterday?
Sir,
So see,
I was out.
okay, first of all, what you need to do is write the full structure of this HCHO in order to understand the mechanism. So can I write this as this HCHO? Yes or no? Please do respond.
Yes, sir.
Okay, thank you. Now see, this will have CS3 MgBr. Now what you need to do is very simple and very easy. As you know that oxygen is more electronegative element, so it will attract or withdraw electron from carbon, and it will have negative charge. This will have positive charge. Now you also know that this carbon is more electronegative than magnesium, so this will have delta negative, this will have delta positive. What you need to do is this negative will go to this positive and this positive will go to this negative. So first of all, you are going to show this hydrogen and hydrogen, and this whatever is this alkyl group will go to the carbon, and you can see the double bond will be broken and it will be singly bonded O minus, and then this Mg plus will go with this and there will be Br. So this is our adduct part, not the not the main product. Now what you need to do is hydrolysis. What you need to do is hydrolysis, and H2O has two parts, H plus and OH minus. And again the same nature. What is the nature of charge? This positive will go to the negative. So what we will get? The rest will be same. The rest will be same like CH2 and then this CH3. And then this you can see O. Who will go to O? H. Now you can see this negative and positive will be cancelled, and this OH will go to positive because this has negative charge, MgOH and you can write this compound in a more specific way, that will be CH3 CH2OH. Now what is the name of the product? That is ethanol. Got it or not?
Yes,
Hamza
sir.
Sekhani. Okay. Please do it, and then I'm going to give you another question which is also very easy. In the same way, you have to do it.
Done, sir.
So, very good. What about you, Hamza and Fawaz?
Sir, 1 minute.
Okay. Please let me know, Hamza and Fawaz, when you are done with this.
Done, sir.
Very good. Fawaz, you are not responding now. Now I'm going to give you another question. CH3 CHO reacting with CH3 MgBr. Then we will get a product A. And after hydrolyzing this, we will get a product B and C. B is the main product. Nafisa,
Yes, sir.
so why are you late?
Sir, sir, I accidentally, sir, I'm accidentally late because
Okay, okay. So Nafisa, we are uh, doing the preparation of alcohol from Grignard reagent. I will explain soon again. So Nafisa, look at the first here. Preparation of alcohols from Grignard. Sorry. Yes, preparation of alcohol from Grignard reagent. So as you know about Grignard reagent from the previous chapter, that is RMGX, right?
yes, yes, sir.
Now see, these alcohols are basically produced by reaction of Grignard reagents with aldehyde or ketones. So I just took an aldehyde or ketone general. This is ketone. So what will happen? This double bond, O, C double bond O, as you know that oxygen is more electronegative element, so it will attract or withdraw electrons from carbon. So it will have positive, it will have negative charge. And now you can see RMGX. R, that means alkyl group, carbon containing group, which is non-metal. That means that is electronegative. And this is metal electropositive. So it will have delta negative charge because it will attract electron from magnesium, and it will have delta positive charge. Now what you need to do is the nature of charge. Positive attracted negative, negative attracted positive. So this positive R plus will go to, sorry, R minus. R minus, you can see delta negative will attack on carbon because it has positive charge. So it will be like this. It will be looking like this, like this. This bond will be broken, and this R will go and make bond with carbon, and this bond will broken. R single C single bond O. It has negative charge. It has positive charge. So this Mg plus X will come to O. This is the first step in which an adduct or intermediate will form. And after this, we will do hydrolysis. Hydrolysis, that means reaction with water. And as we know that this has two components, H plus and OH minus. Again, the nature of charge, positive will go to negative, negative will go to positive. So this will we get. And this is the byproduct. Got it?
Yes, sir.
So please take a screenshot.
Yes, sir, I took.
Okay, very good. Now see, this was the first question I had given. Please take a screenshot. Wait a minute. Let me slide it little down. Now take.
Yes, sir, I took.
Now attempt this question. Please do let me know when you are done with this.
Sir, A would be propane.
AA is an adduct. So just let me know the name of the product of B. Is there
Okay,
any
sir.
answer from Sneha? Should I explain, Sneha? Fawaz, Hamza,
No, sir, got
what is the name of the product, Sneha?
sir, I'll just do the structure. Wait a second.
You get the structure. See, I'm going to explain. See, it's very simple. CH3, can I write it like this? CH3CHO, and reacting this with CH3MgBr. So what you need to do is oxygen is more electronegative, so it will attract this, so it will have delta negative, and this will have delta positive. In the same way, you can see this is metal, this is non-metal, and carbon is more electronegative, so this will have delta positive, this will have delta negative. Now what you need to do is this positively will be going to this, because one of the bond of carbon will be broken, and this negative, wait a minute, I just did it wrong. Carbon is more electronegative, so it will have delta negative charge and it will have delta positive charge. Now you can see this negative will be attracted by this positive, and this negative attract this positive. So what we will get, first of all, I'm going to write the same. This is CH3, this is hydrogen, and this CH3 will come here, and the bond between carbon carbon was doubled, now it will be single, and this is negative and this will be positive, Mg plus, and then Br. After this is an adduct, this is an adduct, and we are going to do hydrolysis of this. That means H plus and OH minus. So this positive will go to this negative. So we will get CH3CH, and then can I write CH3 above, and then OH. And you can see this Mg plus will have OH because negative positive, and this Br. Now I'm going to write this as CH3, CH, CH3, and OH. So this is basically propane to all, propane to all. Is that clear to everyone?
Yes, yes, sir.
Please do write it. Let me know when you are done with this. Very good, Sneha.
Yes, sir.
Fawaz and Hamza.
Sir, 1 minute.
Okay, take your time.
Done.
Okay. Now I'm going to give you CH3, CH2, CHO, and then CH3, CH2, MgBr. Please do it correctly. Then we will get A, and after hydrolysis, we will get B. Basically, B is for main product.
Sir, we'll get butane tool.
Butane to wall. Okay, that's good. But do the steps. What about you, Sneha and Hamza? Have you got the answer? Nafisa, are you done with the steps?
Yes, sir.
Okay, just match it. So what will be there? This is basically CH3, CH2, and then CH. I'm going to write it here. H and double bond O. Your answer is wrong. Did you say butane to all, right?
Yes.
How many carbon here?
3, no,
And how many carbon here?
2.
Total carbon 5. Now see, this is basically CH3, CH2, MgBr. Now what you need to do is very simple. There will be delta negative, there will be delta positive. This will have negative, this will have positive charge. So this negatively alkyl group will come to this carbon, and this positively MgBr will come to this oxygen. Now you can see this is basically CH3, CH2. Now see this, I'm going to write this hydrogen with CH, and this will be coming here. So it will be CH2, CH3. You are not going to write CH3, CH2, because if you are going to write CH3 first with this carbon, the carbon of CH3 will have 5 bond, which is not possible. Now you can see this will have O negative, MgBr, Mg plus, and Br. Now you are going to do hydrolysis H2O, that means H plus and OH minus. H plus and OH minus, this positive will go to negative, and you will get the main product as CH3, CH2, CH, and then OH. And you can see the downward will be CH2, CH3. And I can also write as CH3, CH2, CH, and OH at the bottom, and then CH2, CH. So the answer will be pentane 3 all. Got it? Nafisa, Hamza, and Fawaz.
Yes, sir.
So please write it and then let me know when you are done with this.
Sir,
Yes.
sir, can you explain again?
See, this is wait. Yes. Fawaz, this is
Yes, sir.
your CH3CHO. So can I write this? Yes or
Yes, sir.
no?
Yes.
Now I told you that this is double bond O. So oxygen is more electronegative element, so it will attract carbon's electron. So it will have delta negative charge, and this will have positive charge because its electron is gaining by, or it is losing its electron. That's why it has positive charge. Yes or no?
Yes, sir.
Now this is CH3CH2 MgBr. This carbon is bonded with magnesium, and carbon is more electronegative. That's why there will be delta negative and there will be delta positive charge. Are you getting my point?
Yes, sir. Yes.
Now you know the nature of charge: negative attracted by positive, positive attracted by negative. So just break this bond and this bond and add this carbon to this. So I just wrote CH3CH2, and this CH and this carbon will be bonded with CH2 CH3. That's all. And there was double bond, so one of the bond will be broken, another will be left there with oxygen. So single bond O minus, and this MgBr will go to oxygen, so it will be Mg plus Br, O minus MgBr. Now what you need to do is hydrolysis. Water has two parts, H plus and OH minus. Positive will go to negative, then you will get this. I just wrote it in another way: CH3, CH2, CH, CH2 to look easy. And the byproduct, you can see Mg is there, OH will go to Mg, OH, and Br is there. So this is the byproduct. Please let me know when everyone done with this.
Yes, sir. Finish.
Fawaz, Sneha, and Hamza.
Done, sir.
Okay. I'm going to change the slide. and the mechanism will be same for aldehyde as well as ketone. So I'm going to give you a very simple question. CH3C and reacting with CH3 MgBr. Let me know the name of the product. And this A will be hydrolyzed, that means reacting with water. Then B. Please do this first. It will be done on the same in the same way.
So it will be propane 2 plus MgP.
No, it's wrong answer. Do you know what does prop means? How many carbons? How many carbons
3.
prop means? 3. And how many carbons does this have? 3. And what is the number of? Since they are
Yes,
combining,
sir.
the product will be of the combination of the carbon. The product will be of 4 carbon, no? As you
Yes,
know
sir.
the reaction, as you understand the reaction, since whatever is the carbon in Grignard reagent, that goes and added into this. Are you getting my point? So please do it again carefully in the same way that I just explained, and you will get the answer. What about you, Sneha?
Sir would be butyrol.
But to all. It's also a wrong answer. Should I explain it, Sneha? No. Nafisa? Sneha, are you trying?
So I'm not getting the
Okay, no problem. See, I'm going to explain, and it's very simple. When I explain, it looks very simple, but when you are going to attempt, it's very tough, right? See, oxygen is very more electronegative element. So what it will do? It will attract. Just do a step by step, and you will get your answer definitely. If it will take or withdraw electron from carbon, what charges it will have? Delta negative? Yes or no? Just respond me, and you will get your answer. Fawaz, Sneha, Nafisa.
Yes, sir.
Yes, sir.
Yes, sir.
Now, since carbon is donating or the electron of carbon is withdrawing by oxygen, so it will have positive charge. Now see, magnesium and carbon. Carbon is since non-metal, it is more electronegative element, and magnesium is less electronegative. It is metal, it is electropositive element. So magnesium's electron will be attracted or will be withdrawing by carbon. So it will have delta negative, it will have delta positive. Now what you need to do is just whatever is the number of whatever is the alkyl group, just transfer it to the carbon. Negative will be attracted by positive. Now you can see, since oxygen is making only one bond, because this bond will be broken, because the electron present between oxygen and carbon, oxygen will gain electron or withdraw electron from carbon. That's why it has negative charge and carbon has positive charge. Are you getting my point? Now you can see this carbon has a CH3 here, so I'm going to write it here. And now you can see this CH3 is negatively charged and this carbon is positively charged. So break this and transfer to this. Now you can see this is positively charged and this is negative. So it will go Mg plus Br. Is that clear to everyone up to this? Is that clear?
Yes, sir.
Now what you need to, Sneha and Hamza and Fawaz, you also reply. Response,
Yes, sir,
please.
understood.
Please do respond. Now see, H2O. You are going to do hydrolysis. H2O has two parts, H plus and OH minus. Now it's very easy. Nature of charge. This positive will go to this negative and this will be eliminated. So what we have here, CH3, CCH3, CH3, and this will be OH, alcohol. And you can see Mg and this OH will go to in between Br and Mg. This is the byproduct. And I can write this like this also, CH3. I just put OH at the bottom and you will get this. Propane 2 all. Propane 2 all. Sorry, 2-methyl propane 2 all. The name will be 2-methyl propane 2 all. It's very simple, very simple. So whatever is the number of carbon in reactant will be the number of carbon in reactant will be same to the number of carbon in product. So here you can see 3 carbon and 1 carbon. Total carbon in the reactant is 4, and you can see here in the product 4 carbon is there. 1, 2, 3, 4. Please do write it and let me know. Then I'll move to the next part.
Done, sir.
Thank
Done,
you.
sir.
Very good. So I will request all of you first to understand and then start writing, because if you are going to write it first, yeah, might be there will be problem to get the concept. So should I change this slide, Fawaz and Hamza? Okay. Now see, I'm going to give you same question, not a very different question. Let's see who got it and who does not. A, and when you get the adduct or intermediate A, do hydrolysis and you will get B, the main product. I'm not talking about the byproduct. Everyone done with this? Nafisa, are you done with this? Sneha, what about you? Fawaz, Hamza,
Yes, sir.
do you get the answer?
Yes, sir. I got the answer.
Okay, okay. What is the name of the product?
Sir, that only I was doing. I got this structure, that final structure I got.
Okay, then do the IUPAC name also.
Yes,
Nafisa, what about you? Sneha,
Doing, sir.
Sir, pen to wall.
pen to all. Eh, isn't it pentane to all? Will it not be pentane or pen 2? Pent that only represents number of carbon.
Pentene to
In
wall.
in ein that represents basically the nature of bond. So it will be pentane, right?
Yes, sir.
Okay, let me check it. So can I write this as CH3 C double bond O CH3? And can I write this as it is CH3 CH2 MgBr? Now see what happens here. It's very simple. Again, do the same negative, positive. This will be delta negative. There will be delta positive. So this whole part will become and connect with this. Now you can say CH3, C single bond O minus, and this negative part you can see will go to oxygen. So it will be Mg plus Br. And now there is CH3 already, and this part will go here, CH2, CH3. This is our adduct part. This is our adduct part. And now we are going to do H2 hydrolysis. That means addition in water, H plus and OH minus. So this positive will go to this negative. You will get a product CH3 COH, and then CH3 was there, and then CH2 CH3, or we can write directly CH3 C. This CH3 I'm going to write it on top, and this OH on the bottom. On the bottom. On the bottom, I'm going to write, and this CH2 CH3 on the right hand side, CH2 CH3. And you know that this negatively will be going. This negative will go to this positive, and the byproduct will be same MgOHBr. So first of all, if you are going to name it, it will be 1, 2, 3, 4. So the name will be butane. No, wait a minute. You can see there is a branch, that means the name will be 2-methyl bute and 2, not pentane 2. Is that clear, everyone?
Yes, sir.
Okay, please let me know when you are done with this.
Done, sir.
Nafisa and Sneha
Yes,
and
sir.
Hamza. Okay. Now, whatever I am going to ask, please answer that. Can you tell me the degree of alcohol in this compound? Degree of alcohol.
Tertiary,
Yes, 3 degree. It is 3 degree. OH is connected with this carbon and this carbon is 3 degree. That's why it is tertiary alcohol. Just remember from where this tertiary alcohol comes. Ketone, yes or no?
yes, sir.
Now, this is also ketone. Tell me the degree of alcohol. Where is alcohol? Tell me the degree of alcohol. What is the degree of alcohol?
3 degree.
3 degree. Again, 3 degree alcohol, tertiary. Everyone getting it? Tertiary alcohol. Now, tell me the degree of alcohol. Tell me the degree of alcohol.
Secondary.
It is secondary. And where does it comes from? Propanol. That means aldehyde. Yes or no?
Yes, sir.
Now, tell me the degree of alcohol here. Tell me the degree of alcohol. Fawaz,
Secondary.
you can also answer secondary. And this is ethanol. That means aldehyde. Now, again, tell me the degree of alcohol. Tell me the degree of alcohol here. And we can write it like this. This and this are same. Fawaz, what is the
1
degree of
degree.
alcohol here? 1 degree.
Sir,
And
1.
what is this? Is methanol. It is also an aldehyde. So see, the question can be asked: which type of degree, either secondary, primary, secondary, tertiary alcohol can be produced with which one of them? Basically, I just want to tell you, aldehyde except methanol. Aldehyde except methanol gives secondary alcohol when react with Grignard reagent. Except methanol, all aldehyde react with Grignard reagent to give secondary alcohol. Is that clear?
Yes, sir.
Yes, sir.
Now the second point is that every ketone, or you can say all ketone, react with Grignard to give tertiary alcohol. Keep that in mind. When ketone react with Grignard reagent, it will always give you tertiary alcohol. So that's why I'm going to write general equation of this and you will get it. Please write with me. So here is the HCHO, that means methanol, react with RMGX. R can be anything, methyl, ethyl, propyl, butyl. X is bromine, chlorine, iodine. Then we will get RCH2OMGX. And then after hydrolyzing it, after doing hydrolysis, you will get RCH2OH. You will get RCH2OH along with the byproduct, that is MgOHX. And if you are going to use any other aldehyde other than methanol, then I'm going to write R dash. Wait a minute, RCH2 R dash it will be. It's okay. Just don't make it. Okay, R dash MgX. Other than aldehyde, you will get secondary alcohol. The product will be CH. This will be R dash. This will be OH. Wait. R, CH, R dash, and OMGX. And after hydrolysis, you will get RCH, R dash, OH, and the byproduct will be same. This is MgOH. Thanks. Myself is handy. Now, if you have ketone, and you are going to react this with RMGX, R dash MGX, you will get this OMGX, and after hydrolysis, you will get RCR dash, then R, then OH, and MgOH. Please write this so you can see methanol will give 1 degree alcohol. Other than methanol, any aldehyde you are going to use will give 2 degree, and ketone will give tertiary alcohol. Are you done with this?
You see.
Fawaz?
Yes, sir.
Okay. So write a point about this reaction. The reaction produces a primary alcohol with methanol. And the secondary alcohol with other aldehydes. And tertiary alcohols with ketone. And I will give you another question. Let me know when everyone done with this.
Done, sir.
Very good. Everyone done with this? Now there is a question for you. A reaction of butane 2 with methyl magnesium bromide
Yes, sir.
followed by hydrolysis. Please do this first. Nafisa, are you done with the question? Fawaz, are you done with this question?
Yes, sir. Almost.
Nafisa,
Yes, sir.
are you done with this question? Please do let me know. What about you, Hamza? Sneha?
Done, sir.
What is the name of the compound? IUPAC name of compound, Sneha? Nafisa, is there any doubt or everyone? Is there any problem in solving this type of question? It's a very important question in this chapter. Nafisa, Fawaz, Hamza,
Sir,
do you have any problem in solving this question? Butane, butane 2-on. Did you write the structure of butane 2-on? Please answer me honestly. This is what you wrote in your notes for butane 2-on. Yes or no?
sir, no, sir.
So that's why you are making mistake. This is butane
Yes,
2-on.
sir. Yes, sir.
What?
Yes, sir. Yes,
Yes. Nafisa, what about you?
sir. My carbon is on third position. That's only the difference.
Okay, so from right hand side it is on second position, right?
Yes, sir.
Fawaz,
Yes, sir.
it's on second.
Yeah, it's ulta that.
You have written like this,
Yes, sir.
right?
Yes, sir.
Yes,
So
sir. I
it
wrote
is
like.
on second position. Okay, so both are correct. Okay, I'm going to take
Yes, sir.
you take it like this. Now, what is the structure of methyl? Methyl, that means CH3, magnesium, that means Mg, bromide, that means MgBr, CH3 MgBr. Have you
Yes,
written
sir.
this?
Yes, sir.
Sneha, you also reply, please. Now see, this will attract this, so it will have delta negative, this will have delta positive. This will have delta negative, this will have delta positive because it is more electronegative. Just do this. Now see, whatever on the left hand side, what was there? CH3, CH2. And then see, there was double bond. Just break one of the bond between carbon and oxygen. It will have O negative. This positive part will go to this oxygen and it will form MgBr. And what is on the right hand side? CH3 was there. Now carbon making 3 bonds. So who will satisfy the 4th bond? This alkyl group with Grignard reagent. Now what you need to do is H2O hydrolysis, H plus and OH minus. It's very simple reaction. This H plus will directly go to this and this OH MgBr will be with this. So what we will get? CH3, CH2 and then C and then there is O and H is attaching with O and then CH3 and then CH3. This is the main product. What is the name of the product? 1, 2, 3, 4. 2-methyl butane 2-ol. 2-methyl butane 2-ol. Is that correct?
Yes, sir.
What
I
is the
got the same
problem in
answer.
solving this? You got the same answer,
Yes, sir.
but you are not able to name it, right?
Yes,
Fawaz,
sir.
it's
Yes.
very bad. It's very bad because
Sir,
the nomenclature is very easy. You should focus on nomenclature. It is very easy because in the questions it will be given right the major name of the major product. You have done the reaction, but you are not able to name the product. So it's always you will not get the full marks. What about you, Sneha? What is Sneha and Nafisa? What is the problem in solving this?
I got a mistake in middle.
Okay, you have mistaken.
Sir, I
What about
wasn't
you?
able to name.
You were not able to Okay, can I change the slide? Hamza, you are not responding at all. What is the problem? Is there a problem in your mic again?
No, sir.
No, sir. That's good. Can I change the slide?
Yes.
Yes, sir.
Yes, sir.
Okay. Now see, I'm going to give a reaction from the previous question also. Right. Structures of the product of the following reactions. The reactions are very easy. And if you know the reaction and their mechanism, you will get full marks. The first reaction is basically CH3. You just have to recognize the reaction and apply the mechanism, you will get your answer. H2 in the presence of H plus. The second reaction is so easy that I can't even tell you how easy it is. Please do this two question. I am waiting.
Sir, propane to all.
Propane to all, that's good. Is there any answer from any other student? Sneha, any answer for the first one? Hamza,
Yes, sir.
any answer for the first one? So see, recognize the reaction. This is alkene and this is H2 in the presence of H plus. Catalytic hydration. H2 has two part, H plus and OH minus. Now Markovnikov follow. If you have studied it in class 11th as well as class 12th, previous chapter, haloalkane and haloarenes, Markovnikov says that negative part of the addendum will go along the double bond to that carbon which has lesser number of hydrogen. So the product will be CH3CH. Just break the double bond and single bond will be left. Across the double bond, negative will go to that carbon which has lesser number of hydrogen and positive will go to that carbon which has greater number of hydrogen. So the product is propane to all. Is that clear?
Yes, sir.
Hamza Sekhani, Sneha, Fawaz.
Yes, sir. Got it.
Okay. So is there any answer from any one of you for the second? Do you recognize this NaBH4? NaBH4 is basically sodium boron hydride. sodium boron hydride. Also, it will be represented by SBH in exams or in some books. Sodium boron hydride, and this sodium boron hydride is a reducing agent. Reducing agent, and it reduces. Just see, it reduces ketone to alcohol. It reduces ketone to alcohol. Just find where is ketone. Where is ketone? Is this ketone? Is this ketone? Nafisa, can you recognize
Yes,
any
sir.
one of you? How many functional group are there? How many functional group present in this compound? The second compound. How many functional group present in the second compound? Fawaz, Sneha, Hamza, Nafisa. How many functional group present in this compound? Please let me know if you are done with the first question so that I will slide and start explaining for the second question.
Yes, sir.
Please tell me. How many functional group present in this compound? So see, if you don't know, please let me know. How many functional group present in this? What is the name of the functional group present in this? Nafisa?
Two
This is very
functional
basic question of organic chemistry. Two functional group are there. What is the name of the functional groups that you are looking at too? Can you tell me this? What is the name of this functional group? What is the name of this functional group? Two functional group are there. This is ester and this is what? This is ketone. You should know what is the functional group, how to recognize functional group. It's very important. You should look at the previous classes notes like class 11th chemistry and recognize whether which one is how to recognize basically functional group. I will just ask question about that also. So see, what I wanted to tell you is that this NaBH4 is a reducing agent which reduces only ketone and aldehyde. So here is the ketone. So ketone can be easily reduces to aldehyde. So just break one bond, hydrogen, and just make it OH, and the rest is same. And the rest is same. So this is the product you got. Are you getting my point?
Yes, sir.
Can I change the slide?
So what's the name for that?
What?
The product.
Product's name will be basically this is ester, and ester is uh, more senior than alcohol. So this will be treated as functional, basically not functional group. What we call it is, wait a minute, main functional group. So this will be treated as substituent. So it will be like 1 dash 2 dash hydroxy, 1 cyclohexyl, and then methyl ethanoate. Oh, wait a minute, methyl ethanoate. Yes, it will be like this. I'll just give the name of the functional group, then you will get it. First, write it.
Yes, sir. Okay.
Please do let me know when you are done with this.
Yes, sir.
Done, sir.
Done. So see, first of all, how we are going to name it? It's very simple. As you know that ROR, we have named the write the IUPAC name of the what we say ether, and ether has a IUPAC name alkoxy alkane. In the same way, we have ester. We have ester, and its name is basically alkyl alkanoate. Alkyl alkanoate. So if you have something like this CH3, C double bond O, O CH3. So this is methyl methanoate. Its name will be methyl methanoate. Are you getting my point, Nafisa? Sorry, not methanoate. See, we have to decide which one is that means parent chain, and which one is substituent. So this is carbon with only one carbon, and this is with two carbons. So this will be parent and this will be substituent. So its name will be methyl ethanoate. Is that clear to you, Nafisa? Fawaz? Sneha?
Sir, can you explain again?
See, have you understood the IUPAC name of the ether in the previous classes? If we have CH3O, CH2, CH3. So basically, alongside O, we have to decide which one is parent and which one is substituent. So the chain with lesser number of carbon is substituent. That will be with oxy. That means its name will be methoxy, and it's then ethane. In the same way, we have to decide this side we have one carbon and this side we have two carbon. That's why it's substituent and it's parent chain. So methyl methanoate. Nafisa, are you there? No, Nafisa. Sneha? Sneha, am I audible to you?
Yes, sir.
Okay, can I change the slide?
Yes, sir.
Okay. Now see, I have another question. The third question is basically if we have CH3, CH2, CH3, and there is CHO, please tell me the name of the product, IUPAC name of the product.
Sir, 2-methyl butane.
2-methyl was what you just said.
Yes. 2-methyl butane.
2-methyl butane.
Sir, 2-methyl.
Yes. 2-methyl.
Sir, 2-methyl butane.
Butane. But only represents the number of carbon. Aniline represents or OE that
Butanol.
the butanol. See. So see, this is CHO. That means, and NaBH4 is a reducing agent which can reduce aldehyde and ketone only. So it will be reduced as, now see, CH3, the rest part will be same. CH3, CH. Now you just broke one bond between carbon and oxygen. With oxygen, this hydrogen will come, and you can see this is H already, and this H will be attached, and it will be CH. So I can write it in a more easy way to understand: CH3 CH, and then again there will be CH3 and again CH2H. So it's very easy to understand, and you can name it 1, 2, 3, 4. So the name will be basically 2-methyl butane 1-ol, or directly we can write but. That only represents the number of carbon. N in ine represents the nature of the bond. So please write it.
Done, sir.
Done. Can I change the slide?
Done, sir.
Okay. I'm going to give you question. CH3, CH2 that we already discussed about. OH reacting with HCl, ZnCl2. Can anyone tell me? Can anyone tell me what is the name of this reagent? Concentrated HCl plus ZnCl2. Can you tell me the reagent name? Name of the reagent?
Hydrogen chloride and zinc chloride.
No. It's not like that. The reagent name will be like, yes, you can read it like hydrogen chloride and zinc chloride, but the reagent name is known as Lucas reagent. It is famous for
Yes, sir.
this
Lucas.
Lucas reagent. Yes, I was asking for this Lucas reagent. So please write the product. It's very easy. You can do that. And if you are unable to do it, please let me know. See, I'm going to explain it. It's very simple. We studied about the preparation of haloalkane from alcohol. In that, we have studied this. Just remove this OH and add Cl. You will get the answer. But here, it's very important to note that no reaction will take place. there will be no reaction. Why it is so? So I'm going to write a point which is very important for you. Write with me. Primary alcohols do not react appreciably with Lucas reagent. With Lucas reagent. That means basically HClZ and Cl2 at room temperature. If you are going to rise the temperature, reaction will take place, but at room temperature, primary does not react. But tertiary and secondary can do. Tertiary more faster. So what you need to do, just replace this OH with this chlorine, you will get your answer. We have studied this in previous chapter. And the question asked here in NCRT. Please write it. And happy Diwali. This is it for today. I'll see you on next Saturday, and there will be test also. And we will study about the chemical reaction